you're reading people's minds.
So we don't like to use the term mind reading.
These neuroscientists at the University of Texas in Austin say they've made a major breakthrough. They've figured out how to translate brain activity into words using artificial intelligence.
These are different images.
Earlier this month, they published a paper explaining how they had research volunteers listen to audio clips while having their brains scanned by an fMRI machine. Over time, AI algorithms, the very same tech that's behind ChatGPT, were able to figure out what the volunteers were listening to just by watching their brains.
It is just crazy. You can watch how blood flows through the brain, and using AI and GPT and everything else, translate it into words.
Yeah, it's wild that this works when you put it that way.
Thumbs up, Donies.
To test it all out, Professor Alexander Hoot and I had our brains scanned while listening to parts of the Wizard of Oz audiobook.
If I only had a brain.
Big brain. Like obnoxiously big.
All right, Danny, we have a picture of your brain.
I have a brain.
Yep, it looks good.
I was scanned first, followed by Professor Hoot, capturing images of the changes in our brain's blood flow as we listened to the words from the audiobook and showing how our brains interpreted those words.
When she had finished her meal and was about to go back to the road of yellow brick, she was startled to hear a deep groan nearby.
You can see that we're getting recordings every 2 seconds while he's listening to a story. We will feed this data through our decoder and try to predict the story that he's currently listening to.
The next morning, the results were in.
Okay, so it's been 24 hours since we got our brain scanned. You can confirm I have a brain.
Absolutely.
Brilliant.
So we were able to decode some stuff from my brain, not so much from yours. So this is one from my brain. This is from The Wizard of Oz. So on the left side is the actual words that I heard. When she had finished her meal and was about to go back to the road of yellow brick, she was startled to hear a deep groan nearby. And the decoded version of this is on the right. It's, I was about to head back to school and I hear this strange voice calling out to me. So it gets some things right. So this was about to go back, was about to head back. It completely misses some things, like the road of yellow brick versus school. But then it gets this nice kind of example. So she hears something, and then instead of a deep groan nearby, it said a strange voice calling out to me. It means something related, even if it's not exactly the right words.
Still pretty incredible to think that was about to head back as something that just by scanning your brain.
Yeah. I think that's one of the things that's really surprising to us about this. It can get things like that. It can get these entire phrases of exact words. Okay, so here's this same segment for you.
Now, so we expected mine not to be great.
Because we haven't trained the model on you. The whole day I'd be fine, but she wanted me to make it to her place. First I got a little excited about it.
The reason it wasn't able to decode my brain was because the technology currently needs people to sit in the fMRI machine for more than 16 hours, so the AI models can train on specific people's brains.
Are we going to live in a world where, you know, I can walk by somebody on the street and they'll be able to hold something up to my head and they'll know what I'm thinking?
Currently, we're very far from that. That might also never be possible. We can't completely rule it out, but as far as we know, that certainly won't be possible in the next few decades. The real potential application of this is actually helping people who are unable to speak without them needing to get neurosurgery.
Now we have this snapshot of the brain. And
Jerry Tang explained how they used OpenAI's GPT large language model to help decode the brain. The GPT model is made up of millions of pages of text from the internet that the AI trains on and learns how sentences are constructed and how people talk and think.
GPT basically made our predictions a lot better.
But it doesn't just work listening to audio. Professor Hoot showed us what happened when he watched a movie with no sound while his brain was scanned. Watch as the technology is able to decode what his eyes are seeing.
She then took my hand and held it to her lips. She kissed it. I smiled, and she pulled me in for a hug. I got her back for about hours. I had to stop the bleeding and gave her my shirt to put over it. It's pretty good. I don't know, it's a pretty good description of what was happening here.
Wow. Should we be scared by the work people like you are doing?
We think it's really important to continually evaluate the implications of brain decoding and also to start thinking about enacting policies that protect mental privacy and regulate what brain data can be used for.